thanks. Adam, how long is this talk supposed to be?
Like 20 minutes.
All right. Consecutive or concurrent minutes?
Interleaving.
All right. Yeah. So, yeah, I'm actually happy I'm going last because I agree with an awful lot of things that the previous speakers said. So that gives me the opportunity to go a little further out, since they've covered a lot of the basics. I mean, I'm professionally an AI developer for a long time now. I started with a PhD in math, but I loved mathematics. But I mean, at a certain point, I realized, there's a choice to spend your life proving really cool theorems, or like create a superintelligence 1 billion times smarter than humanity, which you can then upload your mind into and prove theorems way beyond what you would have done in a million years as a human. So I got possessed by the AGI bug 25, 30 years ago, long before it was so fashionable as it is now. I'm not going to tell you too much about the intricate details of my AGI work now, because it's complicated and would take a long time, but I'll give some general thoughts on how AGI fits into life, the universe, and everything, and then tell a little bit about a few aspects of the AGI work I'm doing. So, in terms of life, the universe, and everything, first of all, to frame the discussion, I wrote a brief book maybe 7 years ago called The Cosmist Manifesto, the name of which was inspired by Tsiolkovsky, Fedorov, and the Russian cosmists. And a few of the premises there are listed on this slide. I mean, I believe that in the next decades and centuries, humans will merge with technology in various ways. We'll develop sentient AI and mind uploading. We will leave Earth and roam around the universe. We'll create virtual and synthetic realities. We'll re-engineer space-time. Many of the things that religions have promised, analogs of those, will come about through technology, although probably not exactly what religions have promised, such as a heaven could exist in a virtual reality. Reincarnation of a form could exist if you manage to reconstruct someone from traces they've left behind in the world. I think the domain of material scarcity that we now live in is going to be gone, and our great grandchildren will look back and be baffled that people had to work for a living. Like, they'll be, what, you had to do stuff you don't like to do all day every day in order to get some tokens you exchange for, like, food and water and shelter. This will seem bizarre to them in the way that slavery or cannibalism seem strange to us now. I mean, not to say that everyone will be able to get infinite resources. I mean, if you want to spin up a new solar system to play with, there will be competition for resources on some level, most likely, but the era where we have to work and struggle and compete for resources that feel like basic needs relative to our minds and bodies, I think that's going to go away relatively soon. And I think the ethical systems that are prevalent on Earth will change a great deal and become more flexible, which has already been happening in the world as we've moved toward more and more advanced civilizations. So, and this is not just about technology. I mean, amazing new states of experience and social interaction will come out of all this. I mean, what it feels like to be alive and to experience each moment will become quite different. I mean, in the same way that our experience is radically different than that of, say, a dog or a cockroach, or of a primitive tribes person who didn't know written language, mathematics, science, movies, and so forth. So I think a lot of big things are going to change, and above all, this list will probably seem astoundingly archaic in 100 years, once our intelligences are 1 billion times what they are now. I mean, just as, if I asked my dog, what amazing, exciting future would you envision? To be like, all the steak I can eat, and like I can run around in fields and like mate all the time. And they're not going to say, well, I can download all the movies I want, or I can discover unified physics or fly to other planets. So all these amazing things we envision now, these are probably just scratching the surface. And there's a lot of technologies that will be involved in creating this type of future. I mean, there's nanotechnology, synthetic biology, physics, if you're doing space-time engineering, and we still don't have a unified physics. I mean, for virtual reality, there's all sorts of issues with interfacing the brain to computer systems that will generate synthetic realities to feed into us. There's brain-computer interfacing, body modification to let us fly through the air. But among all these technologies, I do think that AI, and specifically artificial general intelligence, is likely to be the most impactful one. And I mean, this is because, as I.J. Good said in the 1960s, the first truly intelligent machine will be the last invention humanity needs to make. I mean, once you have an AGI, that AGI can proceed and invent nanotechnology, synthetic biology, space-time re-engineering, and so forth. And none of these other advanced technologies on the horizon have the same potential to take over the invention process and bring it way beyond where humans have brought it. So my approach to AGI, if you're interested, you can find on Amazon my book, The AGI Revolution, which is reasonably non-technical for a general audience. Or if you're a computer scientist, you could look at the book Engineering General Intelligence, which is sort of the high level. It's 900 pages, but it's sort of the high level abstract of the OpenCog AGI system that a group of us are building, which is a big and complex undertaking. Now the guts of the OpenCog would-be AGI mind are hard to visualize. I mean, the knowledge base inside the AI is a big graph. It's a weighted labeled hypergraph, nodes and links of an abstract sort in the computer's RAM. And we have a bunch of learning and reasoning algorithms acting on these nodes and links. So there's a probabilistic logic engine and the evolutionary learning framework. There's some deep neural nets for dealing with visual and auditory perception. There's an activation spreading system that spreads around attention to different things in the network. And there's a lot of subtlety here. We've solved a lot of problems. We have some more problems to solve. One of the things we're applying this system to, not the only one, but the one that's easiest to show off, is controlling these humanoid robots that we're making in Hanson Robotics in Hong Kong, where I've been based for the last 6 years. So I'm not going to run through all these robot videos I have here in great length, but just give you a little snippet. This is an old human scale Einstein robot from like 10 years ago. Actually, we have a new one that we're going to showcase at the Consumer Electronics Show in January. This is the Sophia robot, which is our most sophisticated one, which looks really uncommonly like a human. And I think this robot has the most realistic facial expressions of any robot in the world. We had her sing at a music festival in Hong Kong earlier this year, which was kind of cool. What was cool is people walked by and didn't know it was a robot most of the time. Then they'd see the plastic hands, which we kept kind of crappy on purpose, and then they, whoa, what's that? Is it a person with plastic hands? No, it's a robot, right? So yeah, we have male robots. The sound here isn't good, so I won't run through it too much, but this video you can find on YouTube if you look up OpenCog Hanson Robots Reasoning. It was a demo where Man Hin, one of our AI developers, he's somewhere in this room, I think, right? He was running the robot through some basic logical reasoning exercises. And see, what else do we have here? Oh, we get the robots to debate each other sometimes. Do you ever play cookie for work? That's kind of funny. In theory, they could learn from each other. Usually, they just get each other more and more confused the longer that they talk to each other. But
how do I know you were telling the truth? By introspection. Possibilities are endless.
We had a great debate among these two robots at the RISE conference in Hong Kong a few months ago, which you could find on Facebook videos. I think if you look at Hanson Robots Rise Hong Kong, and we're going to do that again at the Web Summit in September. And I mean, humanoid robotics is not AGI, it's its own discipline. There's a lot of subtlety to the material science and the control theory and so forth. From an AGI point of view, that gives you two things. I mean, first of all, it gives you a really cool user interface, because everyone loves to see these beautiful robots, and they get people excited in a way that abstract data structures and algorithms aren't going to do. And you know, we do a lot of other things with OpenCog. We analyze genomics data to help biologists understand aging and disease, and we're experimenting with mathematical theorem proving. These things are equally useful for advancing us toward AGI, but they don't reach out to average people as much as the humanoid robots, because everyone can, when the robot smiles, looks them in the eye, and understands what they're saying even a little bit, they're like, wow, there's some intelligence there. So there's that aspect of the robots. They're great for just reaching out to people. But I also think that embodiment in something that can see, hear, touch, and experience the human-like world and interact in the human-like world, that has a big advantage in terms of getting human-like intelligence into the AGI. Because there's a lot of common sense knowledge that we all share as part of our culture. And the easiest way for an AI to absorb that is to be able to enter into our world and absorb it from us directly in interaction with us. So, I mean, our plan is to use these humanoid robots to advance toward more and more capable AI systems. First getting a humanoid robot that can really hold a conversation with you with genuine understanding of what you're saying in the context of what's going on around it. And we're getting there. We're doing a little bit of that, but we're not really there yet. I mean, you'd like the robot to be here to understand it's in a conference room. All these people are sitting in chairs, and they're going to get up and stand and go away. Understand that people can talk to each other, and understand if someone falls asleep, that if you poke them, they'll wake up. Just get basic understanding of the situation that it's in, and be able to discuss based on that, which is what everyone expects of robots from science fiction. We may be a few years away from getting there. I think that we know how to do it, but there's certainly a lot of work to get there. Once you're there, then you're in a very interesting regime, because then you have something that you can teach. Like you can teach it math on the whiteboard, and when you write 2 + 2 = 4, you can show it 2 things here, and count 1, 2, 3, 4 things. I mean, you can connect abstract knowledge with embodied observations and experiences. Then you can start to teach the robot like a kid. And once you get to that point, you can almost say building a full-scale human-level AGI is more of a management problem, because you know you're going to be able to do it by improving the algorithms and teaching it more and more, and you're going to be able to get as many resources as you want to achieve it. And furthermore, I suspect that once you get to a human-level AGI, getting to a superhuman AGI is going to be quite rapid. I mean, not like 5 minutes. It's going to rewrite its code and then rewrite the universe 5 minutes later. But I think it will be years and not decades from a human-level AI to a significantly superhuman AI. Once you've taught that AGI to program computers and to analyze algorithms and to be a computer scientist, I mean, then it can advance quite rapidly, because it can make many copies of itself, which can learn from each other, and it can apply its knowledge to modifying its own source code. And as it modifies its own source code based on its computer science discoveries, it can make itself smarter and smarter and smarter and smarter. And this is the recursive self-improvement that I.J. Good was writing about in the 60s, and Ray Kurzweil has discussed in his book, The Singularity is Near. Now that really only kicks in my view, once you have an AGI that has the intelligence of a human-level adult who's able to understand computer science, algorithms, math, programming, engineering, and so forth. So there's like zero probability, or very close, that some simple AI program is suddenly going to like blast out of control and become superhuman. On the other hand, once you have something that's like a top-level computer scientist, which is a program in a computer that can copy itself to many hard drives and hack its own code, that then getting astoundingly fast progress seems quite possible. There's a lot of unanswered questions here. I mean, people always ask about consciousness and subjective experience, and I think we don't have a solid answer to that. My strong intuition is that a digital computer program that has the same basic behaviors as a human being and the same practical understanding as a human being is going to have consciousness in the same sense that a human being does. But I'm open to being refuted on that if empirical studies come out differently. I mean, an experiment I thought of as if I connect my brain with a wire or some analog to some other human's brain, and I feel their consciousness there on the fringe of mine, then I connect my brain to the robot's brain, and I don't feel their consciousness. I feel just like if I connected my brain to a brick or something. I mean, eventually this sort of second-person experience might convince me this robot is just faking it and doesn't have any actual experience. So I mean, there's a lot of ways that we're not thinking of now that could be used to explore consciousness. I think AGIs can be a very powerful tool for this. Another interesting aspect is what my friends at the Global Brain Institute in Brussels call the global brain. So, I mean, you could take a lot of different AIs around the world, network them together into one sort of AGI Borg mind, but then once we all have the chip in our head instead of in our pockets, which is almost inevitable once brain-computer interfacing advances a bit, I mean, then the chips in our head, which are giving us in-brain access to the internet and in-brain SMS, I mean, these will also connect to the network of AGIs around the world. And then anyone who wants to can jack into this sort of global mind matrix. And if you look at the advance of technology and what we use it for, I mean, we use these things for email, we use them for SMS, we use them for like Facebook Live video streaming. More than anything else, we use this technology to become closer and closer to other people and network together. So I would imagine once we have the in-brain chip, I mean, that there's going to be an awful lot of use of that to network people together into something that even goes beyond being an individual in the sense that we see it now. Now, where that leads, we really can't know. I mean, we may discover aspects of reality that we're just not imagining now. This is scary. Yeah, it's always been scary in human history, and this may be a scarier leap, but it's hard to know, because if we were living in a cave and someone described modern reality to us, we would think this world was pretty scary. I mean, the difference between where we are now and where our primitive tribal ancestors were is awfully dramatic, and a primitive human plunged into this conference room would barely recognize all of us as humans. So I think going into radically new frontiers and changing our way of life and our way of thinking is what humanity has done since we stopped being glorified monkeys and apes, basically. So when Stephen Hawking says AI could end the human race, and Elon Musk is worried that AI may kill everyone, I mean, I guess if you look through human history, there have always been people extremely afraid of radical change, and many of the things they've feared have happened, right? I mean, many of the things that medieval people hold dear are not around anymore, and many of the things we hold dear may not be significant in the future. But humanity has always been evolving into new forms. So I don't want to see an AI just take all of our molecules and repurpose them into extra hard drive space for itself or something. So, I mean, that's what Eliezer Yudkowsky, who's a friend of mine who's talked about this a lot in the US, like to say that the AI does not love you, the AI does not hate you, but he can use your atoms for something else, right? So, I mean, that's not the future I want to see. I can't assign that a probability 0, but nor do I see why that's an extremely likely outcome. So we can't rule out these negative outcomes, but I think that we can do things that sort of militate against these negative outcomes and make them, qualitatively less probable. So I together with my friend Julia Mossbridge in California, we're pursuing a project specifically oriented toward making an AI that will have unconditional love toward human beings. So, I mean, why not? I mean, there's military making killer AIs, and there's Google making AIs whose main purpose is to advertise stuff to people to convince them to buy stuff they don't need. So, I mean, why not have an AI whose purpose is just to love people and be nice to people? I mean, at least let's throw that there in the mix along with all the other AIs. And if you're going to have an AI that self-modifies, becomes smarter and smarter and smarter and smarter, wouldn't it be nice if that AI had core to its design and its motivational system and its values the desire to love and help everybody? I mean, there's no mathematical guarantee that after it reaches IQ of 10 billion, it won't completely switch and start to hate everybody. But still, I mean, I would rather have a benevolent, loving AI become super intelligent than a killer military robot or an advertising engine or an AI hedge fund or something, right? So I think that's quite worthwhile, and it's similar to the reason I'm working on applying OpenCog to medical AI, to curing human diseases, and with some colleagues I'm working on elder care AI in China, an AI avatar that helps chronically ill old people. I mean, if we roll out AI in positive and benevolent applications, as AIs become smarter and smarter, the odds seem higher that the outcome will be good. It's nothing like a mathematical guarantee, but I think it's maybe the best we can do. I've also been thinking a lot about how to make sure that AI develops in a way that's sort of egalitarian across the world economy. I mean, we have a big problem now in concentration of wealth in the smaller and smaller fraction of the population. I mean, the world is getting uplifted generally, but economically it's concentrated quite unfairly in a small percent of the population. And I've seen this a lot in particular because given that OpenCog is a global distributed project, I'm based in Hong Kong, but we have an office with 25 programmers in Ethiopia, in Addis Ababa, and our programmers there are doing reasonably well. But if you walk around the streets in Addis, I mean, there's like people with no medical care and all sorts of diseases, like lying in the sides of the street, and I mean, even on the upper end, people graduate with a degree in mechatronics or computer science, and they end up for their life administering someone's Windows system or something, because there's just not a great variety of tech jobs in that country. So I think AI should be developed and distributed in a way that works against global concentration of wealth and helps everyone. So I'm involved with a group creating a project called SingularityNet, which it's a blockchain-based sort of globally distributed marketplace for AIs. And the idea is that anyone can basically upload an AI or host an AI on their own server, wrap it in our interface, which is a set of smart contracts, and then anyone who wants AI services can access this global distributed network to get AI services. Now this doesn't in itself like feed starving children, but it does provide a global marketplace where a clever AI developer anywhere in the world can insert their AI into this global marketplace, and if the thing succeeds, it can reach customers from anywhere who want AI services, and a certain percentage of the profit generated in this network is then donated to benefit projects that use AI and other technologies to help the needy in the world. So I think there's a lot of things we can do to militate toward positive outcomes, like building AIs that love people and want to help people, and making sure that AI is developed and deployed in a more equitable way around the world. Now these don't prove that AI won't use our atoms for something else, because we're going into a completely uncharted frontier where we don't know what's going to happen. But it seems like the best we can do is to make that seed a seed with as much positive disposition toward all sentient beings as we can, and then as that seed self-modifies and improves itself, we'll watch it and we'll learn as it grows. You know? All right, thanks for listening.